I'd like to talk about initial and terminal conditions. So we're solving a system of ordinary differential equations, right? And what's happening is we have the right-hand side vector, and then those right-hand side contains some unknown volumetric fluids, which we can either use the Argon or Kozenik-Harman equations to empirically calculate them, or solve this linear system that we discussed, or even the linear program. So what's happening is that obviously we need some sort of initial conditions, right, for solving system of ordinary differential equations because it's initial variable problem. Uh, for state variables that we have in our system, mostly concentration of gas phase, temperature, and SR phase concentrations, we need to specify the initial conditions for them, right? One thing that's nice about this simulation is that when we think about cycle, the initial condition, as long as we provide the initial conditions for the very first step, the final condition of a given step will become the initial condition for the next subsequent step and so forth. So we just have to provide the initial condition for the very first step. So if the very first step in our simulation is repressurization, and we assume that the pressure, the initial condition is at a lower pressure, so we need to take account for that, and we can assume some condition like adsorbents are saturated with the light key at the low pressure, and then we can use the isotherm expression to calculate the adsorption concentration at those conditions, and then provide right gas phase concentration to make up for the right pressure along with the right temperature. So you can actually just do a little bit of work at the beginning to initialize this system, but once you do that, the simulation runs fine. And that's pretty much it in terms of mathematical background for the adsorption columns.